For a semi-infinite solid that is initially at temperature Ti, and then all of a sudden we change the surface temperature to Ts, if we plot qualitatively the change of temperature inside the solid, let's say initially this is Ti, and we change that to Ts, and if we plot the heat propagation inside the solid, this is solution of error function as you have seen before. Like that. Now, let's say we want to quickly assess what's the depth that is getting affected by this change in the surface temperature, or what is the depth that the heat is penetrating or the temperature is changing. Now we can't find that one as a penetration depth, so we can call it penetration depth. And that's referred to the depth that's been affected by heat. Let's say, and we can say it, okay, let's say if the solid, and all the point of solid reach to 90% or 99% of the ultimate change that they can reach, we call that one the depth, that depth as a penetration depth. So ultimately, everywhere in the solid, we expect at the very, very long time, if we keep this one at Ts, it's going to reach to Ts. We're going to reach to equilibrium. Now, we define this penetration depth let's call it delta P. Penetration depth is arbitrary defined as the distance, obviously from the surface x equal to 0, which the temperature change is some percentage, let's say 90% or 99% of the ultimate change. So let's say if I assume 90%, then what we want to have here is Tx and T, which for this minus Ts, Ti minus Ts, it's going to be 90% of the ultimate change, okay? The ultimate change from Ti to Ts. And if we define that one, we're going to call this one delta P. This one. This is equal to error function of x over 2 square root of alpha t. Now from table B2, if you go to table B2, and look for which argument here, you will get the error function of 90%, then this value is going to be 115. So in order for having error function equal to 90%, then x over 2 square root of alpha t is going to be 115. And from here, x, which is now our penetration depth at which the temperature change is to 90%, would be 2.3 square root of alpha t. The same thing if, let's say, if we define that at 99%, at 99, then what you're going to get from table B2, this x over 2 square root of alpha t would be 1.82 from table B2. 1.82, or this delta P would be 3.64 square root of alpha t. And this provides us a tool. This is a very useful tool, I would say. This is a tool for quickly assessing the extent of change of temperature in a semi-infinite solid when it is getting, when the surface is suddenly changed to another temperature.